Okay, folks, this is section 1.4, and these are basically going to be applications of section 1.3. Okay, um, so suppose we have a mine shaft. Okay, suppose we have a mine shaft, and this is what the mine shaft looks like. It has the roof, and it goes. We want to know how far down it is. Okay, we know it goes 310 feet back into the wall, and that our angle of depression is 20 degrees. Now this right here, folks, this is called an angle of depression. Okay, meaning that this is our horizontal mark and our angle is depressed downward. An angle of elevation would go upward from the horizontal mark. So basically what we're wanting to do is we're wanting to figure out how deep this mine shaft is. So this is where your trig functions are going to come in. Okay, so notice we have both sides. What trig function relates both sides? Well, that's tangent. And tangent, remember, is opposite over adjacent. So our theta here is 20 degrees. So make sure your calculator is set in degrees. Our opposite side is x, and our adjacent side is 310. So x equals 310 times the tangent of 20 degrees. And so when you multiply that out, you should get 110 feet for the depth. So that's one way of seeing this in application, the mine shaft problem. So let's look at the angle of elevation problem. So our next one is going to be an angle of elevation problem. All right, so suppose we have, and I'm going to make an attempt at drawing. So suppose we have two airplanes. And there are my two airplanes. Okay, so suppose we have two airplanes, and to save time, or because of lack of landing facilities, large jets sometimes need parts or need to refuel in the air. In the military and some civilian companies will use this air-to-air refueling system using this hose that stretches from one plane to the other. Okay, so let's make that a different color. So this hose stretches from one plane to the other. So let's suppose that the angle of elevation of the refueling hose is the angle of elevation is 32 degrees. Now when they say angle of elevation, that should automatically tell you that this horizontal line here, this has to be the horizontal part of the triangle. So this would be our theta. This would be our angle of elevation because it has to go from the horizontal upward to be elevated. Okay, so that's automatically got to be the elevation. It couldn't be up here when you're trying to draw this out in your mind. It couldn't be up here because that would be depressed. This is elevated, okay? This is elevated. It's all about the horizontal line. If you go down from the horizontal, it is depression. Up from the horizontal is elevation. So because of where this hose is, our horizontal line must be right here, okay? So here is our right triangle, okay? So our our theta, the angle of elevation that this hose is making with the other airplane, is 32 degrees. And the letter, we're going to call this side B. Side B here is 120 feet. So what we want to know is, how long is the hose? How long is the hose? So that would be C here. It would be our hypotenuse because it's across from the right angle. So what relates the adjacent side with the hypotenuse? Well, that's going to be your cosine of theta. That relates your adjacent side and your hypotenuse. Now, even though we use the letter B, that's just a variable. A variable is a variable is a variable. So letter B just represents the adjacent side. You have to think of it in terms of opposite and adjacent. Okay? So this is really the cosine of 32 degrees equals 120 over C, because we're trying to find that hose, how long that hose is. So if you cross multiply and divide, you're going to get 120 divided by the cosine of 32 degrees. Now, this book is kind of weird about this. They don't tell you in the problem that they want it to two significant digits, but what they say is this: if the angle is to the nearest degree, like it is here, that you should be rounding to two significant digits. It's on page 28 at the bottom. There's a table that tells you how many significant digits you should round on a side based on your angle. Okay, it's kind of weird. I'll probably be straightforward with you on a test and tell you I want it with two significant digits. I'm not going to make you guess, okay? But that's what your book says. So two significant digits here. You're going to get 141 point something for this answer. Well, two significant digits would be 140, okay? Would be two significant digits there. So keep that in mind. Be careful with your significant digits. All right, and our last example. Okay, last example is a boat is cruising along the coast of along the coast on a straight course. So we have a boat down here, and it's cruising along at a straight course, and there's a rocky point right up here. Okay, a rocky point is sighted at an angle of 31 degrees from the course. So 31 degrees from our course, okay, the boat can see the rocky point. Okay, after continuing 4.8 miles, okay, so after continuing 4.8 miles in that same direction, another sighting of this rocky point is taken at 55 degrees. So at this point, the rocky point is 55 degrees at its sighting. So, how close will the boat come to this point? So we have a right triangle here. Now the closest the boat will ever be is when it forms a right angle with the rocky point. So if we're going to we'll call this Y. That is the closest the boat will ever be to that point. Now we know this distance here, but we don't know this distance from 55 to the right angle. Okay, we don't know that distance, so that's an unknown. So how far is the boat at its closest point? So in other words, what it's saying is solve for Y. Okay, so how do we solve for Y in this situation? Well, let's look at the small triangle. Now this is a difficult problem. On a scale from 1 to 10, this is probably an 8. Okay, this is one of those more difficult ones because we're going to have to go back to college algebra and use our substitution method to be able to get this right. So watch this. Okay, look at the smaller triangle. We have two unknown sides and an angle. So what relates two sides and an angle? Well, in this case, it's going to be cotangent. It's going to be cotangent. Okay, we can say without a doubt that the cotangent of 55 degrees is equal to x over y. Now we chose cotangent. Here because we're going to solve this for x. Now, why are we going to solve this for x? Some of you are going to be thinking, well, tangent relates two sides. Well, we chose cotangent here because we want an easy way to solve this for x. All we have to do to solve for x is just cross multiply. And you're thinking to yourself, well, Mr. Francis, why did you solve for x then? Well, I solved for x for this reason, okay? Because this is our unknown factor. And in order to solve for y is part of the bigger triangle as a whole. So we're going to need to know this whole side of this bigger triangle. So in order to know this, we have to know what x is. So we use the smaller triangle to get x, and we're going to use that information to solve the bigger triangle, if that makes sense. So now let's look at the big triangle. Same thing. Cotangent of 31 degrees is going to relate our adjacent side. Cotangent is adjacent over, think of it like this, it's adjacent over opposite. So what is this adjacent side here? Well, it's actually 4.8 plus x. That is the adjacent side. The other side is our y. Okay, the adjacent side is this whole thing here, and that's 48 plus x. That's the whole side of the larger triangle. So we're trying to solve, our goal of this problem is to solve for y. So go ahead, cross multiply. And then, so that gives us that. Now, I actually know what x is. I solved for x up here. So, in order to solve for y, we need this in terms of one variable. Notice we have two unknowns. When you have two unknowns like this, you can't solve it for y. So we need it in terms of one unknown. We need it in terms of y. That's another reason we wrote this like we did and solved for x. That's the reason we solve for x, is because we want this thing in terms of y, because that's what we're trying to solve for, is y, okay? So we're going to take this, substitute it in for x. So this is y cotangent of 31 degrees equals 4.8 plus y cotangent 55 degrees. So what we need to do is we need to get our y's on the same side. So y cotangent 31, and then subtract y cotangent 55 from both sides. Equals 4.8. Alright, so using our algebra skills, we can factor out a y. And that's going to give us cotangent of 31 minus cotangent of 55 equals 4.8. And now our goal is to solve for y. So we've got y right here. We just need to divide by cotangent 31 minus cotangent 55. On both sides. So cotangent 31 minus cotangent 55. Alright, so divide that out, and what you should get here, to two significant digits, 5.0 miles. And that's as close as the boat will be to the Rocky Point. Now this is a difficult problem, maybe even higher than an 8 out of 10. It may be a 10 out of 10. I would watch it several times, so let's walk through it one more time. We chose cotangent here so that we could solve for x and get everything in terms of y. That's the goal. We use the smaller triangle to find out what x is so that we could get x. so that we use this here to solve our smaller triangle so that we could solve for x and get everything in terms of y. Because when we get ready to solve our big triangle, we're trying to solve for y. And we can't have two unknown variables to be and solve for one. You can only have one unknown and be able to solve for it. So as you see here, when we tried to solve the larger triangle, we had our two unknowns. But because we solved up here and know what x equals in terms of y, we were able to substitute it back in. Now, that got everything in terms of y. Once you have everything in terms of y, you're able to solve for y. And that's what we did here using a little algebra. So I know this is complicated. Watch over it a few times. You'll have one like this on homework so you can practice it. Okay, so keep that in mind. And I hope y'all have a great day. Oh, and be sure and ask your instructor if you have any questions.